notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and moving forward, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to this math exam is to split the exam into two parts. The current structure and format of the CSEC math exam. There is a paper 1 that runs for 1 hour 30 minutes, and it consists of 60 multiple choice questions from all sections of the syllabus as outlined below. Paper 2, 2 hours 40 minutes. This paper consists of 10 compulsory structure type questions from all sections as shown below here. Note that there is no choice. All sections will be tested. Previously, I had mentioned that there would have been a choice, but that was for the previous syllabus, not this one. And then paper 3, if you are in school, you would do what is called an SBA. Your teachers will tell you more about that. If you are not and you take this exam as a private candidate, then you will write paper 032, which is alternative to that SBA. Essentially, you will be given certain data and asked to do certain things with the data, just like the students would have done in the SBA, but then in the SBA, they would have had to get the data themselves. As it relates to the marks, paper 1, 60 marks, which carry 30% of your final grade. Paper 2, 100 marks, 50% of your final grade, and so on. Schedule of videos, sections 1, 2, and 3. All 51 of these videos have been published in their entirety on YouTube. Please make good use of them. Sections 4, 5, 6, and 7 are all completed. Some of these videos have been published on YouTube in their entirety. The others are only partially published on YouTube. Section 8, this is where we are right now, geometry and trigonometry. This is the 5th of 24 videos from this section. And of course, after we finish that, then we will have to go on to section 9, vectors and matrices. Hopefully by the end of May, maybe June 2026. Please note this disclaimer down here. This schedule is just a projection which is not to be interpreted as a contract with anybody. Going back to section 1, number theory and computation. I have divided section 1 into 33 videos, and as I said, they are all available on YouTube in their entirety. And that is because this section forms the foundation on which the rest of the syllabus is based. So these 33 videos here. If you plan to write CSEC math exam, please note that you need to know the times tables from 2 to 12. Since calculators are not allowed in paper 1. Still on section 1, from this syllabus, some of these videos are applicable even in the primary schools, where students themselves, maybe in grades 5 and 6, could look at the videos by themselves. Teachers can use some of these videos in the inverted classroom, and especially parents can use these videos to help their children. For example, if I expand that blue box there, you will notice that video 6 in section 1 says add, subtract, multiply, and divide whole numbers. This is work done in grade 3 in the primary school. And then video 7 says add and subtract and divide decimals. Video 7, that's work done in grade 4. Video 8, add and subtract fractions, and video 9, multiply and divide fractions, and so on. So most of the work in section 1 is actually done in primary schools. So students and teachers at the primary school level and parents of such children can find a lot of help here in the teaching and the learning of CSEC Math Section 1. From Section 2, Consumer Arithmetic, all 12 of these videos have been published on YouTube. Section 3, Sets, all 6 of these videos have been published on YouTube in their entirety, as I previously said. Section 4, Measurement, some of these videos have been published on YouTube in their entirety, the others partially published. Please see directions in the description below for full access to these videos that are only partially published on YouTube, if you need full access. Section 5, Statistics. Some of these videos have been published on YouTube in their entirety, the others partially. Same principle applies. If you need full access to these videos that are only partially published on YouTube, please see directions in the description below. And this applies to section 6 and 7 as well. Section 6, Algebra. These 7 videos have been published on YouTube in their entirety, and these others partially. Please see directions below for full access. Section 7, Relations, Functions, and Graphs. These videos have been published on YouTube in their entirety as indicated here, the others partially. Again, please see directions in the description below if you need full access to these videos that are only partially published on YouTube. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these that you see on the right here. From those, I would recommend these 2 down here, especially as they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CSEC Questions by Raymond Tulsi. And this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions, only specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like, which is this. That's the home page. You follow the home page, you register first, and subsequently log in. This is the URL for that website. This URL will be in the description of this video below, so you can easily click on it and be redirected to that website. Another reminder that this formula sheet that you see on the left is provided for the CSEC math examination papers. This formula sheet. It is included in a full copy of the syllabus. Just in case you do not have a full copy of the syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer, a little better. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination, as I just said. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know how and when to use them. Section 8, which is the section we are currently doing, geometry and trigonometry. This is a print screen from that section. We have completed objective 1 in 2 parts. We have completed objective 2. We are now at objective 3, but we have divided that into 4 parts. We are now at part B, the second part. And we continue with print screen from that section with more objectives and some more objectives, some more objectives. And finally, the last set of objectives, which would take us to objective 17. So as I said, we have finished these 3 up here. The first one is published in its entirety. The other 3 only partially published. We are now here, 3B. When this is finished, it will be published in its entirety. And for the rest of this section, this is a projection of how these videos will be published. Those others will be published in their entirety and these partially. Please make good use of all these videos that are published in their entirety and even those that are partially published, because they deal partially with those objectives as well. So as I said, we are here. 8_3. Construct lines, angles, polygons using appropriate instruments, and we have some explanatory notes. As you already know, this is quite a lot to handle in one video. So I have divided this objective into 4 videos. Please look at them in sequence because the first video, A, would be the easiest, and then it gets progressively more difficult. So this is section A that we finished in the last video. We now need to go on to section B, which has to do with construction of triangles given certain data. This is what we are doing now in video 5. After that, we will have to do video 6, which is part C, and then the next video, which is part D, to take care of this objective 8_3. So we begin with this first subsection of part B. Construct a triangle given 3 sides. Construction of triangles. Construct a triangle given 3 sides. Now the triangles we are going to construct are called unique triangles. Unique triangles are triangles that do not have an equivalent. This means there is no other triangle that has the exact dimensions or shape. There are 4 ways of stating unique triangles. The first one is given 3 sides, which is what we will begin with here. Then, given 1 side and the 2 angles at its ends, that is what we will do next in this video. And then 3, given 2 adjacent sides and the angle between them. That's the third way of stating unique triangles. And finally, 4, given the hypotenuse and any other side of a right triangle. So we will look at these 4 in sequence, beginning with 1 and so on. So we begin here. This is a question. Using ruler and compasses only, construct triangle ABC with AB equal 5.0 centimeters, side BC 7.0 centimeters, and side AC 6.3 centimeters. Well, the first thing we will do, as always, is make a labeled sketch, which will look like this. We take the longest side and let that be the base, and the longest side here is BC. So we draw a line like this, and we call it BC, and we label it 7 centimeters. And then we take the other two sides, put it somewhere up here. AB is 5 centimeters. From here to there is 5 centimeters. And AC, which is here to here, is 6.3 centimeters. So your triangle will look something like this when it is finished. That's your sketch. So first of all, we will construct correctly the base, BC, and write in its dimension. That's the first thing we will do. Next, we will measure on our ruler using a pair of compasses 5 centimeters. 5 centimeters. Place the metal point here and make an arc like that up there. So from B to anywhere on this arc would be 5 centimeters. Thirdly, we will extend our compass to 6.3 centimeters from 0 to 6.3 centimeters. Then we will put the metal point here at C and make an arc like that to cut that original arc, which means that this point here is both 5.0 centimeter from B and 6.3 centimeters from C, that point there. So all we have to do is draw bold lines from A to B and from A to C, finish the labeling, and that is the required triangle. Draw a triangle given 3 sides. It doesn't matter how many other persons draw this triangle. It doesn't matter where they put A, where they put B, and where they put C. If the dimensions hold, then all those triangles will be the same triangle. They will get the same triangle. It may look differently when you look at it to begin with, but they are the same triangle. They are unique triangles. So this is a finished product. Construct a triangle given 3 sides. Construct triangle PQR with PQ equal 4.5 centimeters, QR 6.8 centimeters, and PR 10 centimeters. In this case, we are given 3 sides. Best practice, make a sketch and use the longest side as the base. So if you make a sketch here, PR 10.0 centimeters. That's PR 10.0 centimeters. PQ is 4.5 and QR is 6.8. So Q is going to be somewhere up here, such that PQ is somewhat shorter than QR. So we'll have something like this. This will be 4.5 centimeters. This 6.8 centimeters. So this is what our sketch looks like. PR 10 centimeters, PQ 4.5 centimeters, and QR 6.8 centimeters. Let us construct the base, PR 10 centimeters. So draw a thin line longer than 10 centimeters. And this, of course, is R. From R, bold PR, and we have just constructed the base PR 10.0 centimeters. Now from P, we need a point somewhere over here.
that would be 4.5 centimeters, and at the same time that point must also be from R 6.8. We can arc like that. Anywhere on this arc to P is 4.5. Next I need 6.8. Come from over this end here, make an arc like that, where these two intersect here is Q. It's a unique point. From P to Q is 4.5 centimeters, and from R to Q is 6.8 centimeters. So all I need to do now is draw a bold line from here to there, and then from here to there, and write in the dimensions 4.5 centimeters and 6.8 centimeters. Now in this case, I chose to let this base here be PR 10.0 centimeters. Instead of letting PR be down there, somebody might have chosen RQ, but it is still 6.8 centimeters, and might have drawn this triangle. Now this is the same triangle as that. So if I turn this paper around like this, you can clearly see where the two triangles match in terms of sides and in terms of label. Q and Q, R and R, 6.8, 6.8, 4.5, 4.5, Q, P, that's P down there, 10 centimeters, R, P, 10 centimeters. So even though these two triangles look different, they're not. They are the same unique triangle.
If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So we finished that. Construct a triangle given 3 sides. Now we are here. Construct a triangle given one side and the 2 angles at the ends of that side. So this is the question. Using ruler and compasses only, construct triangle DRG with RG equals 6.0 centimeters, angle DRG equals 75 degrees, and angle DGR equal 45 degrees. So we will make a sketch first. You are only given one side, so we will use that as the base, which would be RG 6 centimeters. And then up here you will sketch an angle of 75 degrees. Over here you will sketch an angle of 45 degrees. Extend them until they reach at D. Once you can do that, constructing that triangle becomes very easy. So we construct the base, RG 6 centimeters. Construct that as you see it here. Then from this end, you construct the angle 75 degrees. You know how to do that by now? That is 60, that is 90, bisect that. That is 75. This angle here is 75. So you construct this angle of 75 degrees and you extend it like that. You don't know how far it will go. So extend it somewhat with a construction line. So this is a thin line. Then from this side, you construct 45 degrees. You know how to do that. And this time you extend it from G until it touches that other line we had on the side. Use a bold line because you know that point there will be D. So you are almost finished. All we have to do now is bold RD and put in the measurement of the angles. So this is the finished product. This is what you are required to do. Construct a triangle given one side and two angles at its ends. We were given this one side and those two angles. Construct. We were not using a protractor. Now, if angles required are not multiples of 15 degrees, remember you can construct any angle that is a multiple of 15 degrees. That's what we did in the last video. Now, what about if this angle here had been 40 degrees? Then use your protractor to measure that 40 degrees. You would still have constructed the triangle even though you measured that one angle. Everything else was constructed. Your finished product should look like this. DRG, 6 centimeters down here, 45 degrees there, 75 degrees there, and the construction line should be shown in pencil.
Using ruler and compasses only, construct triangle DRA with RA equals 7 centimeters, angle DRA equals 60 degrees, and angle DAR equal 30 degrees. Best practice, let's make a sketch. Since we only have one side, that one side will be our base. We will call this side R and that end A. This is 7 centimeters. Angle DRA, which means at R, we will construct 60 degrees. So something here, 60 degrees. And DAR, which means at A, we will construct 30 degrees, which may be something like this, 30 degrees. So our triangle eventually will look something like that with D up here. So RA, 7 centimeters, angle DRA, which is this angle, 60 degrees, and angle DAR, which is this angle, 30 degrees. So let's construct the base first. Let's draw a thin line that represents the 7 centimeters. We are going to construct it properly. At this point, R, this is A, we bold this line, and write in 7.0 centimeters. At this end, we will construct 60 degrees. Now, this is fairly easy to do. That line going through there will be 60 degrees. Since we don't know how long this side will be, we will just draw a construction line like that. We don't know the length of this line, so we just draw a construction line through it. Come from the other end and we want 30 degrees. That point there will give us 60, but we want 30. So we will bisect the 60 to get 30 from here through here. That will be 30. We can draw a proper line here because we know how far this will go. From here to there. D. Bold from D to R. And write in the specifications of over here was 60 degrees. Over here was 30 degrees. And we have just constructed this triangle given one side and the two angles at the ends of that one side.
That was done. This we just did. Principle 9. Construct a triangle given two sides and the angle between them. So now let us look at this question. Using ruler and compasses only, construct triangle GHK with GH equal 5.5 centimeters, HK equals 7.0 centimeters, and angle GHK equal 105 degrees. Construct. So let's make a sketch. Always make a labeled sketch so you could see what you have to do. So we use the longer side as the base, which is HK 7 centimeters. You could use 5.5, but it's easier to use the longer side. And then you sketch an angle of 105 degrees, extend it 5.5 centimeters. Remember, this is a sketch. Label that G. So your finished triangle will look something like that. Something like that. So we construct the base, HK 7 centimeters. Construct it very neat and nice, like you see there. Then at H, we construct 105 degrees because it does say here 105 degrees. And you draw a nice thin line going through there, a construction line. And then using your compass, measure 5.5 centimeters, that's there, from 0 to there. Place the metal point of your compass at H and make an arc like that, which would mark off 5.5. And label this point G, bold GH. So now you have GHK. You would need to write in here 5.5 centimeters and then draw a bold line from G to K. So this is the required triangle that you had to construct.
Using ruler and compasses only, construct triangle ARY with AR equal 4.5 centimeters, RY equals 7 centimeters, and angle ARY equal 135 degrees. Again, best practice. Let's make a sketch. We will use, since we have two sides here, we will use the longer side as the base. RY 7 centimeters. We need an angle at R, angle ARY at this point. We need an angle that is 135 degrees. Now that will give us 90. So our angle would be somewhere over here, 135 degrees, 135 degrees, and this side will be A. So AR 4.5 centimeters, RY 7 centimeters, and angle ARY 135 degrees. So our triangle will look something like that. It is a sketch. It is not accurate. It is just to give an idea what the triangle will look like. Now, obviously, because this triangle extends this way, we can't start at the end of the page. So we need to start approximately somewhere here towards this end of the page. We are going to construct the base, which is 7 centimeters. So carefully measure 7 centimeters, beginning at a point here, which we will call R. Make an arc like that, which will be Y. From Y, make an arc like that. Bold this piece of the line. That's RY, and it is 7 centimeters. We only have one angle here, which is 135, and we need that angle at R. So let's construct 135 here. Recall that 135, 180 minus 135 is 45. So we will construct 45 this way and consider the 135 over on that side. So that will give us 60. Bisect the 60. That will give us 30. Now at this point we have 120 and 30. That's 150. But we want 135. So we will bisect that 30 so that 120 plus 15 will give us 135. We want that intersection there. We will draw a construction line here, which is a very thin line. But we know the length of this line, which is 4.5 centimeters. And it is exactly that point here, which will be A. We can bold this up to A. And then from A to Y, AR is 4.5 centimeters. AR is 4.5 centimeters. We know RY is 7 centimeters, and we know angle ARY is 135 degrees. And there we have the triangle, given two sides and the angle between.
Completed, completed, completed. Now we are here. The last construction of triangles for this video. Construct a triangle given the hypotenuse and any other side of the right-angled triangle. That's what we are doing now. And this is the question. Using ruler and compasses only, construct triangle PQR with angle PRQ equal 90 degrees, that is the right angle. PR equal 4.8 centimeters and PQ equal 7.0 centimeters. So as usual, we will make a labeled sketch. Well, we know it is going to be a right triangle, and the right angle will appear at R. So you draw a right angle like that. This side here will be 4.8 centimeters. Label that P, and from there to there will be 7.0 centimeters. Now, once you have the sketch, constructing the triangle becomes very easy. Now, in this case, we don't have a base to draw. So we will draw a construction line that will form the base later on and label this point here R. At R, we will construct a right angle. That will be this right angle. And then we will take our compasses and mark off 4.8 centimeters and mark it off on that. So using our ruler and compasses, we measure off 4.8 centimeters, place the metal point at R and mark off there 4.8 centimeters. Label that point P, bold the line PR, the line segment, and write in the dimension here. So we got the right angle, we've got the length of PR. Now what we need is 7.0 centimeters from P to Q. Q will fall somewhere here. So we will take our compass, measure off 7.0 centimeter, put the metal point there, and mark an arc somewhere here where 7.0 centimeters would fall. So we measure 7.0 centimeters. From P, we make an arc on this original construction line that we had. From P, anywhere on that arc would be 7.0 centimeter, but we don't want anywhere. We want this specific point on this construction line. And we draw a nice bold line from P to Q. Of course, we will label down here Q. And this is the required triangle. Another picture of that same triangle, except in this case, a different method was used to get this 90 degrees. A different method here was used to get that 90 degrees. But it doesn't really matter. You get the same right triangle in both cases. And if you approach this differently, as long as you have these dimensions, that the right angle is at R, that RP is 4.8 centimeters, and that PQ is 7.0 centimeters, the triangle will always be the same. That is why it is called unique triangles. Well, as I said, in this case, another way of constructing that 90 degrees was used. You know both ways. This was the method used to construct that 90 degrees. And the other method was 60, 60, bisect that 60, and you will get 90 through there. But it doesn't matter what method you use to construct the 90 degrees, you will still get the same triangle.
Construct triangle DAC with angle DAC equal 90 degrees, DA 5 centimeters, and DC, which is the hypotenuse, 8 centimeters. First of all, we need to draw a sketch. Since this will be a right triangle, let's put a right angle here. This point here will be A, and we could let either this side or that side be D. Easier to put D up here. So DA 5 centimeters and DC, which is the hypotenuse, this is 8 centimeters. So that's the sketch of the triangle we want to draw. It's a right triangle. We're given one side and the hypotenuse. Now in this case, we don't know what the base is. So what we will do, we will draw a construction line like that. Locate a point to the side here, and let's call that A. By the way, this is C. Let's call that A. At this point, we will construct an angle of 90 degrees. And this will give us 90. We measure 5 centimeters. Now we know that this point is D. From D to C, somewhere over here, is 8 centimeters. So we measure 8 centimeters, and from D, mark on this base like that, so that this point here is now C. All we need to do is draw a bold line from D to C, bold A to C, and A to D, and we would have constructed this triangle. So let's finish that. And finally, this is 90 degrees. We don't have this measurement. We do have this measurement, which is 5 centimeters, and we have this measurement, which is 8 centimeters. And so construct triangle DAC with angle DAC equal 90 degrees, DAC equal 90 degrees, DA equal 5 centimeters, and DC, which is the hypotenuse, equal 8 centimeters. Reminder again, the side opposite the right angle is the hypotenuse.
In this part of objective 8_3, we considered construction of 4 unique types of triangles. And that brings us to the end of video 5 based on objective 3B in section 8.